Hey Year 9, welcome to the next exciting linear relationship class. Today we're going to be looking at the difference between parallel lines and perpendicular lines, so let's get into it. First of all, imagine like a set of train tracks. We know train tracks are parallel. If they're in a straight, train tracks are in a straight direction, the two tracks must be parallel to each other. So two lines can be parallel. You could have more than two lines being parallel. I could have lots of lines, all parallel. They will never come in contact with each other. But there's something about lines that are parallel. If lines are parallel, their angle or their slope or their gradient is exactly the same. So we know parallel lines have the same gradient. And this is what we write. We write that the gradient of one line, or line 1, is equal to the gradient of line 2. It's saying both lines run at the same angle. That's what that's saying. But when we talk about perpendicular lines, let's say we have one line. If we have another line that is perpendicular, that means they cross at 90 degrees or at right angles to each other, something different happens. The two lines have gradients, and those two gradients, when you times them together, will always give an answer of -1. So this is what we do. We write the gradient or the slope of line 1, when you multiply it by the gradient or the slope of line 2, equals -1. If that is true, you know the two lines are perpendicular. Here's another way to write it as well. It's a more complicated way, and we'll talk about what this is actually meaning in a moment. So, let's look at the first example. It says, are the two lines perpendicular? Well, let's have a look. Let's call y equals 3x plus 1 our first line, line 1, and we'll call this one line 2. Well, focusing of line 1, because it's in the form y equals, we can know the number in front of x is 3, so we can know that the gradient or the slope is 3. So notice I put a little 1 under the m to say this is the gradient of the first line. It's 3. The gradient of line 2, it's in the form y equals, so the number in front of x is the gradient, so the gradient is -1/3. Notice I put a little 2 under the m, saying the gradient or the slope of line 2 is -1/3. Well, to check if they are perpendicular, we take those two gradients and we times them together. So what's 3 times -1/3? It's -1. And because they times to give -1, we say the lines are perpendicular. If it multiplied together and did not give -1, we'd say they were not perpendicular. And remember, perpendicular means that two lines cross each other at 90 degrees or at right angles. Let's look at our second example. Let's find the equation of a line that's parallel to y equals 2x plus 5, and it goes through the point 0, 3. Well, what we do know, if it's parallel to this line, all parallel lines share the same gradient. And this line, because the number in front of x is a 2, this line has a gradient of 2. So all parallel lines have a gradient of 2 as well. We know 0, 3, if we actually graph it, remember 0, 3, out 0, up 1, 2, 3, that's on the y-axis. So that's called a y-intercept. So that means 0, 3 is a y-intercept. That means b is 3. So we know all parallel lines have the same gradient. If we use the formula y equals mx plus b, our parallel line has the gradient of 2 and a y-intercept of 3, so it's y equals 2x plus 3. I could do this question using the more advanced formula, but we don't use the more advanced formula normally if we're given the y-intercept. It's only if we're given a point that's not the y-intercept that this formula is the one that we go for. But let's show you that it works. We've been given a point on our line that's passing through 0, 3, so the x value of the one point we're passing through is 0, the y value of the one point we're passing through is 3. We know m is 2, we can put those values into our formula and multiply the bracket out. 2 times x is 2x, 2 times nothing is nothing, so we don't have to write anything, plus 3 to both sides, and you get the same answer here as we got here, but this is the formula we'll use if we know the y-intercept. This is the formula we'll normally use if we don't know the y-intercept, if it's going through another point somewhere. Let's look at our third example. Find the equation of a line which is perpendicular to y equals 3x take 1 and passes through this point. Well, let's just think about it. This point here, 0, minus 3, 0, minus 3 lies, we think about it, 0 and then minus 3 is down 3. It lies on the y-axis, which means that point is a y-intercept. This line here has a gradient of 3, but our line is perpendicular to that. So we know that parallel lines will all have a gradient of 3. What will the perpendicular line have? This is the trick. Now, if you know any line that's parallel, so let's actually say line 1 had a gradient of 3. That's the same as 3 over 1. That means if they're at right angles or if they're perpendicular, this is the shortcut. This is what I said about the weirder version of the formula earlier on. To find the perpendicular gradient, you just turn the gradient of the first line upside down and put a minus in front of it. Because when you think of 3 over 1 times minus 1 over 3, the 3's cancel, you're just left with minus 1. Let's try a different one. What if I had a line had a gradient of 2/3 and I wanted to know the gradient of all perpendicular lines to this one here? Well, perpendicular gradients, put our gradient upside down, it's called taking the reciprocal, and put a minus in front of it. Here's a different one. Let's say the gradient was 1/4. Let's make the gradient minus 1/4. All perpendicular lines would have a gradient of 1/4 when we turn it upside down is 4 over 1. Put a minus in front of the minus 1/4 and that's like a plus. So the gradient is plus 4 because we're not going to write 4 over 1. So the shortcut to finding any line's gradient is to look in front of the x. If you want to find the gradient of any line that's perpendicular, you take that number in front of x, take the reciprocal, that means turn it upside down, and put a minus in front of it. When we look at this question here, think of 3 as 3 over 1, turn that upside down, it's 1 over 3, we put a minus in front of it. There's our perpendicular gradient. We also know the y-intercept, so let's use our formula. Y equals mx plus b. We know m for the perpendicular line, we know the b, so it's y equals minus 1/3 x take 3. This will also work using y minus y1 equals m bracket x minus x1, but this is the fastest way to do it. Try some questions now and enjoy the experience.